called hot Jupiters are some of the strangest worlds found beyond our solar system. Hot Jupiters are planets that orbit too close to their stars to sustain life. New observations show that the hottest of them all is stranger still, prone to planet-wide meltdowns, so severe that they tear apart the molecules that make up its atmosphere. Called Kept-9b, the planet is an ultra-hot Jupiter, one of the several varieties of exoplanets found in our galaxy. It weighs in at nearly 3 times the mass of our own Jupiter and orbits a star some 670 light years away. With a surface temperature of 7,800 degrees Fahrenheit. This planet is the hottest found so far. Now, a team of astronomers using NASA's Spitzer Space Telescope has found evidence that the heat is too much, even for molecules to remain intact. Molecules of hydrogen gas are likely ripped apart on the day side of Kept-9b, unable to reform until their disjointed atoms flow around to the planet's night side. Though still extremely hot, the night side's slight cooling is enough to allow hydrogen gas molecules to reform. That is, until they flow back to the day side, where they are torn apart all over again. Megan Mansfield, a graduate student at the University of Chicago and the lead author of a new paper revealing these findings, says, "This kind of planet is so extreme in temperature, it is a bit separate from a lot of other exoplanets. There are some other hot Jupiters and ultra-hot Jupiters that are not quite as hot but still warm enough that this effect should be taking place." The findings, published in astrophysical journal Letters, showcase the rising sophistication of the technology and analysis needed to probe these very distant worlds. Science is just beginning to peer into the atmospheres of exoplanets, examining the molecular meltdowns of the hottest and the brightest. Kept-9b will stay firmly categorized among the uninhabitable worlds. Astronomers became aware of its extremely hostile environment in 2017 when it was first detected using the Kilodegree Extremely Little Telescope system, a combined effort involving observations from 2 robotic telescopes, one in southern Arizona and one in South Africa. In the astrophysical journal Letters study, the science team used the Spitzer Space Telescope to pass information from this infernal giant. Spitzer, which makes observations in infrared light, can measure subtle variations in heat, repeated over many hours. These observations allow Spitzer to capture changes in the atmosphere as the planet presents itself in phases while orbiting the star. Different halves of the planet roll into view as it orbits around its star. That allowed the team to catch a glimpse of the difference between Kept-9b's day side and its night. In this case, the planet orbits its star so tightly that a year takes only 1.5 days. That means the planet is tidally locked, presenting one face to its star for all time, as our moon presents only one face to Earth. On the far side of Kept-9b, night time lasts forever. But gases and heat flow from one side to the other. A big question for researchers trying to understand exoplanet atmosphere is how radiation and flow balance each other out. Computer models are major tools in such investigations, showing how these atmospheres are likely to behave in different temperatures. The best fit for the data from Kept-9b was a model that included hydrogen molecules being torn apart and reassembled, a process known as dissociation and recombination. Kept-9b turns out not to have huge temperature differences between its day and night sides, suggesting heat flow from one to the other. And the hot spot on the day side, which is supposed to be directly under this planet's star, was shifted away from its expected position. Scientists don't know why. Yet another mystery to be solved on this strange, hot planet.